So we have to construct a third degree polynomial. So my highest power is going to be a 3. It has to have zeros at -2, -1, and 3, and it has to contain the point 2, 11. Well, if -2, -1, and 3 are zeros, what does that tell me about the polynomial? What's that mean?
There's
3 x-intercepts, okay? So I have 3 x-intercepts, and those 3 x-intercepts are at -2, -1, and +3, okay? So I really don't know. None of them are going to be bouncers, because if it's a third degree, then the most I can have is 3 intercepts. It would have to go through them all. Because in order to be a bouncer, you would need an even power, and that would make your power greater than 3. I don't know if it's uphill or downhill. There's no way of figuring that out yet. But I do know it goes through the point 211. So I know at +2, I'm clear up here at 11. So I've got a point way up there. All right? So I'm supposed to construct this polynomial. If these are x-intercepts, I should be able to write the polynomial in factored form. Okay? So what would this look like in factored form if I wrote these zeros? Okay, x plus 2, x plus 1, and x minus 3. That makes sense to everybody? If these are the x-intercepts, then in factored form, it has to look like this, right? Now, the only thing I don't really know if there's a compression stretch out here, okay? Maybe there's a 2 factored out of one of these, or a 12 or something. I don't know what that might be, so I'm going to put an A out front for whatever compression stretch number there might be. Now, I do know that this polynomial goes through the point 211. So anytime I have a point, I can plug the x value in for x and the y value in for y, right? So whenever x is a 2, y is 11. So I could replace all these x's with 2s, this y with an 11, and that would allow me to solve for a, so that I can figure out what that a value would be. So if I do that, I'm going to have 11 equals a times 2 plus 2 times 2 plus 1 times 2 minus 3. So this is where x used to be, and this is where y used to be. I've replaced x with a 2 and y with an 11. Everybody okay with that? Okay, so now I need to get the a by itself. What can I do to get the a by itself? How can I work that out? What's 2 plus 2? Okay, so 2 plus 2 is 4. 2 plus 1 is 3. And 2 minus 3 is -1. Everybody with me on that? Yes. All I did was work out these parentheses here. So if I multiply these 3 numbers together, I get a -12. So 11 is going to equal a times -12. All right, so if I solve for a, what am I going to get? Remember what the x always goes on the bottom, so -11/12. So there's my value for a. Okay. So if that's my value for a, now I'm going to rewrite this thing. Now y is equal to, what was it, -11/12 times x plus 2 times x plus 1 times x minus 3. Now, I would love it if they would let you leave it like that, but I'm pretty sure they make you actually multiply that whole thing out. Okay? So, what should be the best strategy for multiplying that thing out?
Distribute -11/12.
I actually would probably save that till the end just because it's a fraction. Okay? Because if you distribute that, that's going to make one of these look really yucky, and then you're going to have to multiply that really yucky thing through another one, and it just keeps looking nastier as you go. Okay? So I would probably hold off on that till the end. It's not a wrong move mathematically, it just makes it kind of yucky for you. Which would be the easiest two to multiply together first? Maybe just these two? Okay, so if I multiply those two together first, how do I multiply those together? You can use a box, you can use double distributive property, you can use FOIL, whatever method works for you, right? So I need to take x times x, x times 1, 2 times x, and 2 times 1, right? So what will I get if I do that?
X squared
I'll get an x squared when I take x times x.
plus 3x.
Then I get x times 1 and 2 times x. That's 1x plus 2x, right? So that gives me the 3x. Is everybody okay with where we got the 3x? Okay? And then 2 times 1 is 2. And then I still have this x minus 3 on the end. Everybody okay with that?
You have 11 halves.
Oh, 11 twelfths. Thank you. Everybody okay with that? Okay, so what's the best way to multiply a 2 by 3? I would put it in a box, right? You can use double distributive if you want without the box, no problem. But the box makes it pretty easy to keep them lined up. So 2 by 3 box. With a x minus 3 over here. And an x squared plus 3x plus 2 up here. Does that make sense? So now I just multiply them together like a multiplication table. X times x squared is going to give me what?
X cubed.
Okay, and then I need to take x times 3x, which will give me 3x squared, and x times 2, 2x, negative 3x squared, negative 9x, and negative 6. So now, when I go and put those together, over here, I'm going to have y equals negative 11 twelfths times what? What's my first term? X cubed. Now my x squareds looks like they cancel out, right?
But do you still need to write them?
Nope.
Okay, 'cause I got
Negative 3 and positive 3 give you 0, so we don't have to write those in there. But these two are like terms. I can put those together. That gives me
negative 7.
negative 7x, and then I have a minus 6 left on the end. So now I've got to take all of that times negative 11 twelfths, and then I'll have my answer. So y is equal to negative 11 twelfths times x cubed. Plus, why do I have a plus sign?
Because it's already
Negative times negative is a positive. And if I have to take 11 twelfths times 7 over 1, what will I get?
No, 77.
77 over 12. So 77 over 12 times x, right? And then once again a plus sign because I have a negative times a negative, right?
Plus 66 over 12.
Plus 66 over 12. Won't that reduce? Okay, so 66, 33, but those were both divisible by 3, right? 60, 11 halves. Okay, which you could just cancel the 6 and the 12 also, 11 halves.
It was fine. You just made me 12 over.
You can multiply this by 12, yes.
Yeah, okay.
But what would that help you? How would that help you?
Couldn't you do
You mean instead of having to take 11 twelfths times 6?
Yeah.
Yeah, you're right. You wouldn't have had to have, but in the end, you still have to do the same thing. You still have to take 11 times 6, which is 66, and then when you divide by the 12, you have to reduce it anyway. So, but yes, that would be a legal mathematical move. Okay? Everybody okay with example 5? Okay, now we're ready for example 6. All right, let's, example 6, we're going to construct a second degree, that means a quadratic, right? Second degree polynomial.
Wait, did you sketch it?
We kind of did, but we didn't need to. Construct a second degree polynomial with zeros at negative 3 and 2, and f of x is going to approach negative infinity as x approaches negative infinity. So it's telling me the end behavior. So I want to construct a second degree polynomial with zeros at negative 3 and 2, and f of x will approach negative infinity as x approaches negative infinity. So this means as x marches off to the left, my y values are going to go where? Down, right? So I know a second degree has to be a parabola, a quadratic. So I have a parabola. And in this parabola, as x goes to the left, y goes which way? Down. So what does that tell me about this parabola? It's got to be a sad face, right? If you've got a parabola and as x marches off this way, y is going this way, going down. Okay? As x goes this way, y goes down. That tells me it's got to be a sad face parabola, right? So I'm talking about a sad face parabola. And I know my zeros are at what?
-3 and 2.
So that means in factored form, this would be x plus 3 and x minus 2. Opposite of these. X, if that's a 0, then in factor form, I have x plus 3 and x minus 2. So I have y is equal to that. But since it's a sad face, what do I need to put out front here? A negative. Now, it does not this time give me a specific point that the parabola goes through, correct? There's a lot of parabolas in the world that will meet this criteria. That goes through these 2 points and is down. So theoretically, I could put any number out here I wanted, but you don't need to do that. You just have to meet the minimum requirements, that it goes through these 2 points and that it's a sad face. It does not give me a specific point that it has to go through. So now if I multiply that out, I'm going to have a negative sign. I'm going to have an x squared. X times x is x squared. X times negative 2 is negative 2x. X times 3 is 3x. So I end up with what, 1x in the middle?
Yes.
And then 3 times negative 2 is negative 6. And now I just need to distribute my negative. So negative x squared, negative x, plus 6. And there's my answer. When you're practicing, you can try typing it in like this and seeing if it'll take it in factored form, but I'm pretty sure you got to multiply them out. Everybody okay with that example? All right, we have one more type of problem to do. So we'll do a couple of those examples and then we'll be done. So this is example 7? Okay, example 7. It'll say, the instructions will say, is k a 0? And then they'll give you the polynomial, let's say 3x to the 4th minus 17x cubed minus 8x squared minus 30. And I guess in front of that I should have put a function like p of x or f of x or something like that. So they're going to give you a function, and they're going to tell you that k is equal to some number. In this case, we'll say k is a 5. Okay? So k is a 5. Here's my function, and it wants to know if k is a 0. So what does that mean? All right, is it an x-intercept? What else does it mean? It means if you plug that number in for x, you will get what? 0. Okay? So anytime you take a 0 or an x-intercept, because remember, what's the y value on an x-intercept?
0.
Right. The y values on x-intercepts are always 0, correct? So if you plug in an x-intercept, you should get a y value of 0. So anytime you plug a number in here, if it comes out to give you 0, that's why zeros or all x-intercepts are also called zeros. So if it says find the zeros, we said that's the same as saying find the x-intercepts. So when they're saying is k a 0, that means is it an x-intercept? And if I plug an x-intercept in for x, I should get a y value of 0. So there's 2 ways to do this problem. I will show you both ways. I don't care which way you do it. All right, I'm going to show you first of all by substitution. We just plug 5 in for x, and we see if it actually comes out to be 0. That's method 1. So we find p of 5, and we see what we get. So 3 times 5 to the 4th power minus 17 times 5 to the 3rd power minus 8 times 5 to the 2nd power minus 30. So you're going to want to type that in your calculator and see if you get 0 for an answer. And I think it's a good idea to use a parentheses, because if you happen to have a negative on your number, then the parentheses will make sure and take that negative sign to whatever power you have. Okay? So get out your calculator app, type that in, and tell me what you get. So if you're getting 480, K is definitely not a 0, right? So these are going to be yes or no questions. So you're going to select no, because P of 5 was equal to what? Negative 480. So guess what happens when you click no? It'll say, okay, well, if it's not 0, then what is it? And so a little box will pop up for you to type the negative 480 into. Okay, so the answer is no, it's not a 0. So then that box pops up and says, okay, well, if it's not 0, then what is it? And you write in negative 480. Now, that was method 1 for doing this problem. I'm going to show you another way to do this problem using synthetic division. Okay, everybody got this down? All right, so I'm going to shrink that. And now let's do that same problem using synthetic division. So if something is a 0, you should be able to plug it into synthetic division. So I put the number 5 out there. I put all my coefficients on my top row, which is 3. Negative 17, negative 8. Oh, I'm missing a single power of x. I got fourth power, I got third power, I got second power. I have no x to the first power, so I got to put a 0 for that. And then a negative 30. Is everybody with me? What do I do in synthetic division? Drop the 3. I drop the 3. Multiply by 5, I get, what's negative 17 plus 15?
Negative 2.
What's negative 2 times 5? Negative 10 plus negative 8? Negative 18 times 5. That's a hard one. What's that one? 90? Negative 90 plus 0 would be negative 90. And negative 90 times 3 is what? Times 5, I'm sorry. Negative 450. Negative 450 minus 30? Negative 480. So see what synthetic division does for you? It gave us this number, right? Now, if the 5 was actually a 0, then you would get a 0 here, all right? But it's another way to evaluate numbers. Now, this one was easy to do without a calculator. This one we needed a calculator for, right? So if I didn't have a calculator, I would definitely choose to do this problem via synthetic division, okay? And you've been doing these since Algebra 1. You've been plugging numbers into functions, right? Now you know another way to plug numbers into functions where you don't even really need the calculator. Okay, so once again, what would I select for my answer? No. 5 is clearly not a 0 because I didn't get 0 right here. Well, what did it come out to be? Negative 480. Okay? It's good to do just to practice your synthetic division. Everybody okay with example 7? Okay? Let's do last example, example 8. And same thing, they want to know, is K a 0? And this time, K is going to equal negative 4i. And my P of x, or f of x, or whatever function name you want to use, is 4x squared minus parentheses 2 minus 8i times x plus parentheses 32 minus 8i. Okay, well, can I plug this one in the calculator? No, can't do this one because it's got i's in it. I can't even plug this one in the calculator if I want. So I've got two ways to do it. I can plug the I in manually, or I can use synthetic division. I'll do both, okay? So if I'm going to plug in the negative 4i, I'm going to have something that looks like this. 4 times negative 4i squared minus parentheses 2 minus 8i times, instead of x, I put a negative 4i plus 32 minus 8i. Everybody with me? All I did was replace the x's with a negative 4i. Okay, so what do I get if I take negative 4i times negative 4i? Negative 4i times negative 4i.
16 I
But then
I would get a positive 16i squared.
yeah, Yeah, that's what I was.
So I'm just gonna write it like that for now. 16I squared. Everybody okay with me doing that? A negative times a negative is a positive, and I times an I is a squared, I squared, and a 4 times 4 is a 16. Okay, everybody okay with that? Okay, now for the next step, I'm gonna take this negative 4I, and I'm gonna multiply it times this negative out here. So I'm gonna write it as positive 4I times 2 minus 8I. That's the only step I'm gonna make there. Everybody see what I did? I just moved the negative of 4I out front, put it with that negative to make it a positive. So just little steps in that line. Okay? What is a 16I squared equal to? Negative 16. Why is it a negative 16? Because I squared is equal to negative 1 in the complex number system, right? I squared is the same thing as a negative 1, so 4 times negative 16 is what I have there now. All right, let's distribute this 4I. What do I get if I take 4I times 2?
8I.
Okay, I get an 8I. What if I take 4I times negative 8I?
Negative 32.
32I squared. We'll write it like that first, right? 4 times 8 is 32. Positive times negative is negative. I times I is I squared. Okay? And then I have a plus 32 minus 8I. I don't have to have that parentheses on the end there now. Or didn't really have to have it at all in the beginning. What's 4 times negative 16?
Negative 60.
Negative 64. Okay, plus 8I. And what is this going to simplify to?
32.
I squared is the same thing as negative 1, and negative 1 times negative 32 is positive 32. Plus 32 minus 8I.
8I.
Okay, the 8i's cancel.
So does the 32.
And then 32 plus 32 is 64, and 64 and negative 64 equal 0. So the question was, is K a 0? Answer is yes. Yes, it is a 0. Okay, now, that's method 1. Method 2 would be to use synthetic division, which we're going to do. Okay, everybody okay with method 1? Do you think synthetic division will be easier?
Probably.
I think so, because that was kind of long and drawn out.
Yesterday with eyes in the
Yeah,
synthetic
that was kind of long and drawn out there, wasn't it?
Yeah.
Okay, so let's shrink that up. Okay, synthetic division, what do I put outside in my little box?
Negative 4I.
A negative 4I. Okay, what were my original coefficients? A 4. Then now you got to be careful here. I have a negative sign and a parentheses with a 2 minus 8I. That's my next coefficient. Okay, and then my last coefficient is 32 minus 8I. Everybody okay with that? I had 3 coefficients, so I separated those 3 things. Now, you may want to, at this point, go ahead and distribute this negative. If you go ahead and distribute that negative, you're going to end up with a what?
Negative 2 plus 8I.
Negative 2 plus 8I. So let's replace that with a negative 2 plus 8I. Okay? All right, so now take this 4, bring it down, and now what do I got to do?
Multiply 4 times negative 4I.
4 times negative 4I is what?
16I.
Close.
16.
Negative 16I. So where do I put the negative 16I?
Underneath 8I.
Underneath the 8I. And you can use a 0 under the 2 if you'd want. So 0 minus 16I. Okay. Well, now I need to bring those down. So what's negative 2 plus 0?
Negative 2.
And what is 8 minus 16?
Negative 8I.
Everybody okay with that?
Yes.
All right. So the next step is always to take whatever's down here times this. Now remember that you have 2 terms. So I'm going to kind of do this as a side note up here. I'm going to take negative 4I times this. So negative 4I times negative 2 minus 8I. All right, so what is negative 4I times negative 2? Close. Negative times a negative is a? So it's a positive 8I. And now I'm going to take negative 4I times negative 8I, which is positive 32I squared. And I squared is really a negative 1, so I end up with 8I minus 32. All right, so when multiplying this times this, I ended up with 8i minus 32. That has to go right here. So I want to line them up. I'm going to put the negative 32 underneath the positive 32 and the 8i under the negative 8i. So I have negative 32 plus 8i. And when I put them together, I get 0. So what was the question?
Is K a 0?
Is k a 0?
Yes.
Yes, because I got a 0 right here. Does that make sense?
Yes.
Okay, we're done with 5.2.